Okay, linear inequalities. Linear equations are equations. They have equal signs, two variables, and when you graph them, you get a straight line. A linear inequality doesn't have an equal sign. It's got an inequality instead. Either greater than or less than, or greater than or equal to, or less than or equal to. Okay. And the solution, an ordered pair that makes the inequality true, so that's just one solution, a point that's in the shaded region. When you graph an equation, you get a straight line. When you graph an inequality, you get a shaded area on the graph. It's not just a line. It is a shaded portion of the graph. There's technically more points. There are more areas that can be solved for an inequality than an equation. An equation just gives you a straight line. An inequality gives you a shaded area. Now you're basically dividing the graph in half and shading one side or the other. Okay. Now, some basic properties. Okay, does everybody have this down? Yeah, I'll pause for a second. Okay, so some of the properties of inequalities. And these focus on what the inequality is. If y is greater than the equation, it's a dashed line. If it's greater than, it's a dashed line. You're going to draw a line. Your line is either going to be a dashed line or a solid line. If y is greater than, it's a dashed line because it can't actually be that number. It has to be greater than that number. And it's going to be shaded above the line because it's everything that's greater than that. All my y values are more than that. Okay. If I have, actually, let's do this. For example, if y is greater than 2x minus 4, I graph the line 2x minus 4. My slope is 2, make it a fraction of 2 over 1. My y-intercept is -4. So I put a dot on -4. And I have a slope of 2 over 1, go over 1 and up 2. Okay. And because it's greater than, it's not or equal to, it can't actually, y actually is not those values. Y is greater than those. I have a dashed line. Okay, that's my equation. It's not a solid line, it's a dashed line because it's greater than. It's not or equal to. And I shade everywhere above. That's how you graph an inequality. Now, you're either going to have a dashed line or a solid line. If y is less than my equation, I have a dashed line. And everything's going to be smaller. Y is smaller than what I have. So it's going to be great. It's going to be shaded below the line. Okay, these are going to be important parts of your notes. This is how you do it or you don't do it. It's okay. It's okay. Trust me, it's okay. Now, so if it's greater than or less than, if it's greater than or less than, it's a dashed line. It's shaded above or below. If it's or equal to, it's a solid line because it can be that. It can be that value. Okay, if y is greater than or equal to my equation. It's shaded, and it's shaded above, but it's a solid line instead of a dashed line. By the same token, if y is less than or equal to, it's a solid line and shaded below. So if we're looking at it, shall I put it on here? So if it's greater than or less than, it's a dashed line. But if you think about it this way, when we did the dots, those were open circles, right? And if we had or equal to, what did we have? We had filled in circles. We have filled in lines. Kind of goes together. The ones where we had an open dot when we did the inequalities on the number line, those are ones where you have dashed lines. If you have the inequality where you would have had a solid dot, you have a solid line. So for example, if I graph this equation over here, my slope is -3/4. My y-intercept is 4. I graph the same way. Plot my y-intercept is 4. Do my slope is -3/4. So I go over 4 and down 3. And then I go, okay, this is a solid line because it's or equal to. It can be that, so I have a solid line. Is y less than or greater than? Or is y less than or greater than? It's less than, so I want everything below it. So that means I shade below. Everything that is in that shaded area works. In this case, everything that's on the line works. Everything that's not in the shaded area doesn't work. Okay? Just like, you know, when you had x equals and you were working with the number line, when you had x equals, you just put a dot here or you put a dot there. But when you had an inequality, what you have? You had an arrow pointing everywhere. Was everything bigger or everything smaller? It works the same way here. It's everything bigger or everything smaller. So you're shading one side of the line or the other. Okay? Now, a couple of parts that are going to help you a little bit with your homework. Okay? First one, identifying solutions. Sometimes you have an inequality and you're given an ordered pair, and you're asked, does this work or not? We did this with equalities. You do this with inequalities. You just take the x and y and plug them in. Take my x, take my y, plug in my equation. 2 greater than 1 minus 3. And you want to see, is this true or not? Is 2 greater than -2? Yeah. So this is true. Yes, it is a solution. That's what you do. Plug in the values. Is it true or not? You do the next one. Plug in -3, -7, see if it works or not. Same equation, see if it works or not. Okay, so let's go ahead and plug those numbers in. X is -3, Y is -7. So I want to know if -7 is greater than -3 minus 3. Is -7 greater than, -7 greater than -6. Is -7 greater than -6? No. Questions? Okay, so let's do a little bit of graphing here. Now, you can try to remember whether you shade above or below. That'll usually work. But there are other ways to decide which side of the line to shade. You still graph the line the same way. I have the equation y equals x minus 2. My slope is 1. My y-intercept is negative 2. The first thing I do is I plot my point, my y-intercept, and I have a slope of 1. And whenever I have a slope of 1, I don't like to go over 1 and up 1. Put them close together. I like to go at least 2 and up 2. As long as the amount I go over and the amount I go up is the same, it's still a slope of 1. But I don't like to go over 1 and up because it's really close. I like to go like over 2 and up 2. Now, my first question to you is this a shaded line? Or sorry, is this a solid line or a dashed line? It's a dashed line because it's not or equal to. I don't have the little line. I don't have the filled-in line. It's a dashed line. Now, I can shade this line based upon y being greater than or less than, which tells me, gentlemen, y is greater than, so it should be shaded above. However, there is another way to tell which side of the line to shade. You test. Pick a point that's not on the line. You choose any point that's not on the line. I'm going to pick the easiest point, the origin. The origin is 0, 0. X is 0, y is 0. You plug that point in and it happens, we're talking about it right here. Pick any point that's not on the line, see if it's a solution. So I picked the point 0, 0. And I tested into my equation. Is it true or not? Is 0 greater than 0 minus 2?
Yes.
Yeah, 0 is greater than negative 2. This is true. So that means the point that I picked is in my shaded area. It works out true. The point that I picked is on my shaded side. If it had come up false, I'd shade the other side of the line. Questions so far? If you can graph a line, you can do this. Some of you need to work on graphing your lines. Okay. Graphing in standard form. We've done this before as well. Cover up the y. Let y equal 0. What do we get? We get 5x equals 10. And you do equals for finding your points. I know it starts out as an inequality, but we do equals for finding our intercepts. Divide both sides by 5. I get x equals 2. It means I have a dot for 2 on the x-coordinate. Do the same thing for my y. Let x equal 0. Gives me negative 2y equals 10. Divide by negative 2. Many of you screwed this part up on one of your performance tasks. And you get y equals negative 5. Not positive 5, negative 5. So I go to negative 5 on the y-axis, and you put a dot. Now I need to draw my line. Is my line going to be solid or dashed? It's going to be dashed because it's greater than. There's no or equal to. And now I have to shade one side or the other. And this is where it gets a little difficult on this one. It's not that hard. I can't go by the greater than or less than sign because I can only do that. I can only use this when it's y all by itself. If it's y is greater than or less than, and then you have everything else on the other side, you can use this to decide to shade above or below. If you have it in standard form like we have it here, you can't do that. Just because it has greater than doesn't mean it's going to be above. Not when I have my x's and y's on the same side. I don't know for sure. What you have to do is you have to pick a point and test it. The easiest point to pick is 0, 0, the origin. Pick the easiest number. As long as the line does not pass through the origin, pick the origin. Put in 0 for x and 0 for y. 0 for x minus 0 for y greater than 10. Is 0 minus 0 greater than 10? No. This is no. Because it's no, the point I picked is not in my shaded area. This came up false. That's no bueno. I shade the other side. What? Doesn't matter. You just plug them in. If it's true or false, you decide. That tells you which side of the line to shade. If it's true, the point you tested is in the shaded area, you shade the side that has the point. If it comes up false, you shade the other side of the line that doesn't have the point you tested. The point doesn't work. It's not a solution. That's it. Okay. So on Monday, we're going to use this to solve systems of inequalities, because it's the only way you can solve systems of inequalities. Okay. Tuesday, we're going to review for your test 1 week from today. 1 week from today is your Chapter 6 test. Okay, that'll be 1 week from today. Any questions?